And then, of course, there's the cells themselves, the neurons, and the synapses on the order of a micrometer, and the molecules, the neurotransmitters that do things for us, like make the reward system work or cause us to be addicted, and so on, are at this level. And in order to have a real hope of understanding the nervous system, what we've had to do really is explore the brain at all of these levels of organization. At one time, it might have been thought that if you knew everything there was to know about the cells, that you would be able to make a leap to behavior. And that clearly is not the case. Next slide. I think we'll just go on to the next slide. Now, one of the things that the history of science, and I'm going to get to consciousness and free will in a moment, but I want to put it all in this setting because I think it gives perspective in a way that just plunging into the topic straight off does not. One of the things that's important to remember is that science is full of surprises. And you start off thinking that you understand a phenomenon or thinking that you have a way of drawing boundaries around it. And then as the science progresses, everything changes. And I'm going to use a very simple example to illustrate that. People were interested in the nature of fire. So what is the phenomenon? What are we going to identify as fire? Should we, for example, begin by defining it? Well, you can't very well define it if you don't really know what it is. So how does the science proceed? Well, it proceeds in the following way. We make a rough guess as to what the paradigm examples are on the basis of observable, superficial, perhaps, similarities. And then what we try to do is probe those phenomena in order to find out the reality behind the appearances. Now, when people began to study fire, they assumed that these things, sorry for the misspelling here, by the way, they assumed that those things were all examples of the same thing. They were all examples of fire. Burning of wood, what went on in the sun, what lightning was, and what happened in the behinds of fireflies. Now, what's very interesting is that as the science proceeds, the category flies apart. It turns out that the burning of wood is nothing like what goes on in the sun. What goes on in the sun is nuclear fusion. That the burning of wood, although superficially it might seem to have a lot to do with what goes on in the sun, is actually more like rusting. And that turns out to be a real surprise. And the idea that burning of wood had more to do with metabolism than it did with lightning was something that Lavoisier had already realized. So lightning is something different yet again. It's incandescence, and phosphorescence is what goes on in the behinds of fireflies. Now, I use this example because when we talk about a phenomenon such as consciousness, we're in much the same state as we are when we talk in the very early stages of science about fire. We don't really know how to define the phenomenon. We don't really know whether we're talking about a single phenomenon that will have a single underlying neural mechanism, or whether we are actually lumping together a whole lot of things that will fly apart. Now, the other thing that's also important, I think, in the history of science is that sometimes a category that seems solid and seems to touch reality in a very firm way just turns out to be screwball. And a very good example of that, I think, is the notion of impetus, which served an important role in Aristotelian physics. Impetus was what kept things moving, right? So if a ball was rolling along, it's because it had impetus. And when it stopped, it ran out of impetus. And they thought of impetus as an actual kind of stuff. What happens with Newton? It all changes. There is no impetus. The idea that we needed to explain any aspect of what makes anything move by appealing to impetus turned out to be wrong. So it was a very puzzling thing at first, because something that had seemed to be even observable turned out to not be a real thing at all. And that, too, I think, is a possibility as we reflect on the way that psychology and neuroscience are going to come together. That some categories that seem to us intuitively very obvious and secure, we may want to have a very different look at and a very different perspective on once we understand the neuroscience. Next slide, please. So when we address the phenomena of consciousness, we might think that we ought to begin by defining it, but since we know so little about the thing we're talking about, we need to do what we have done in earlier stages of other sciences, to assemble together the variety of things that we think fall under the category and then see what happens, sort of let the science do its work. We may be talking about, in some instances, sensory awareness, visual awareness, proprioceptive, somatosensory, and so forth. But we sometimes mean something different. We sometimes mean imagery, visual imagery or auditory imagery. But there can be very different things yet again that people mean to pull together under the category. Next slide, please. Sometimes there are sort of non-specific feelings that have to do with consciousness. Feelings of well-being or unease, feeling ill, feeling that you are a thing that is a self, awareness of spatial relations, and perhaps most fundamentally, awareness of temporal relations. Whether those can all be explained by a single unified mechanism is something that remains very much an open question. Next slide, please. So can we do it at all? Do we have a chance of explaining the nature of something like consciousness, or as I shall talk briefly at the end, something like decision-making? Well, if it is a phenomenon that is a product of the brain, then we surely should have at least a good go. As things stand, there are really two somewhat different approaches. These two, I think, are complementary. I don't think that they are inconsistent with one another, but they follow slightly different hunches. And how it actually plays out remains to be seen. Francis Crick and Christoph Koch have taken a very interesting strategy, which I call the direct route. Their idea is this. Next slide, please, and I'll come back to the indirect route in a moment. Begin with the following hypothesis, a very straightforward hypothesis. There should be a difference in the brain in the following two conditions. In the first condition, the stimulus is present and you're aware of it. In the second condition, the stimulus is present and you're not aware of it. There should be a difference in the brain. If we want to understand the mechanisms behind sensory awareness, so let's just focus on sensory awareness, we should be able to find out what that difference is. Now, that's not going to give you a theory of consciousness even if you get that difference, but it will give you a very interesting foot in the door. So can we actually make progress that way? And what would be a useful experimental beginning? Suppose that you think for a moment, you're listening, you're looking at things. There's lots of your sensory system that's sending signals forward into your cortex of which you are not aware. One is the movement of your tongue. Now you will be aware of it. But while you were not, there must be a difference in the brain between your being aware of the movement of your tongue and you're not. Now, progress has actually been made, and it's been really quite interesting, not so much with that particular example, but with another example within the visual system.